Share my screen. All right. Good morning, everyone, and thank you for joining us for this session of 6th grade life science. My name is Svea Anderson. I'm the ASTA ambassador and host for today's webinar. This webinar is being recorded. I will be assisting Leslie today by watching the chat box and answering any technical questions. The chat box can be found at the bottom of your screen. Our presenter today is Leslie Horn, and she is from the Higley School District. During the past year, 60 middle level teachers participated in the Arizona Science Teachers Association's intense professional learning program called a Deeper Dive, constructing three-dimensional units. Teachers worked in professional learning communities where they learned how to utilize 5 tools and processes for implementing the NGSS. The Arizona Science Teachers Association, along with the BSCS and the Arizona Department of Education, facilitated the training. With new Arizona Science Standards, or the AZSS, as you might see them, adopted, teachers learned how to create instructional units that implemented 3 major dimensions: the science engineering practices, or the SEPs, the cross-cutting concepts, or the CCCs, and disciplinary core ideas. These dimensions, along with the major instructional shifts presented by the standards, are new and challenging to Arizona educators. So one of the conceptual shifts with the new standards requires teachers to move their instruction from fact-based understanding to understanding phenomena. And so, as you know, students currently learn scientific facts, but are often not able to explain the importance of these facts and their interconnections to the world around them. To build capacity among Arizona's teachers in developing and implementing 3-dimensional instructional units that are aligned with the new AZSS, the Deeper Dive program had the following objectives. To build capacity through collaboration with science teachers statewide. To learn tools that translate science concepts, practices, and performance expectations into instructional sequences that form 3-dimensional science instructional units. To think deeply about learning and teaching to develop a clear vision of science education that is coherent, focused, and rigorous, and based on 3-dimensional best practices, as outlined in the framework for K-12 science education. And to collaboratively align instructional units to the Arizona Science Standards and share throughout the state. So the ASTA is delighted to have Leslie Horn from Higley Unified here to share the unit that she's prepared for you. So at this point, I am going to go ahead and stop my screen share. And Leslie, you're welcome to take over. Thank you.
Wonderful. Thank you so much. I apologize, I'm getting used to Zoom. My school district is a different resource. So I'm trying to figure out how to move the bar. There it is. Okay. Good morning, everybody. Welcome to 6th grade life science 3-dimensional unit. I am one of the creators of this unit, along with 3 of the teachers in my school district, a 6th grade teacher, a 7th grade teacher, and an 8th grade teacher. And we all worked hard last year, and we hope that you are able to utilize what we have created in your classrooms. So in today's webinar, we're going to utilize the chat for questions and or comments, and again, keep your microphones off if possible and your video disabled if you choose. I'm going to go ahead and disable my video at this point just to keep down from the distractions. So the purpose for today is to provide an overview for you for the 6th grade life 3-dimensional unit that we created during the Deeper Dive professional development. And I just want to thank the ADE and ASTA for this learning opportunity. I have fallen in love with using the tools for creating curriculum. And as the science instructional coach for my district, it has become very useful in helping the teachers I work with understand 3 dimensions even better and to create lessons for their classrooms. So we are sharing the 6th grade life. And I'm going to go over big ideas, standards, science and engineering practices, cross-cutting concepts, phenomenon, storyline, and of course, lesson highlights during all of this process. For our unit, we actually have 2 units with 2 learning sequences each. So we're going to talk briefly about each one of those. So unit 1 is the flow of energy and matter in an ecosystem. And the first learning sequence has the big idea that all energy comes from the sun, and it is through the transferring of this energy that the ecosystem cycles. And we're working with the students to understand that it comes from the sun and then cycles through that ecosystem. So it's not a big drastic idea, it's just that big basic foundational concept. For this unit, starting with the instructional sequence 1, we started with 6th grade standard 14. So there's going to be a lot of constructing models in this learning sequence because the SEP within the standard is that constructing a model. So when we were picking the SEP elements, you'll notice those on the left here, they are all focused on developing and using models, but we did add in constructing explanations and designing solutions as a secondary SEP for our instructional sequence. When looking at the cross-cutting concepts, which are on the right-hand side box, we are focusing with energy and matter because our big idea is based on the energy transference, but we are also looking at systems and system models. So we want to make sure that students understand that this is a big system and we are working within that system, and there's going to be inputs and outputs of that system that will interact with one another. The using science we did in this unit is to develop and use models to represent these relationships. So you'll notice almost all of them have to do with the constructing models or in addition to that based on this standard. So in this learning sequence, we have many phenomenon, and we start with our anchor phenomenon, which is a bottle ecosystem. So we have the students create an ecosystem in a bottle to watch and to manipulate throughout the unit so that they can see the changes and a system right in front of their eyes to model the system that is around them in the world. You can also use the alternative phenomenon of the Biosphere 2, which is a great resource for us here in Arizona. We have also included a seed, and then we talk about how it turns into a tree. We've added a variety of ecosystems, and we have included an example where someone has created an ecosystem in their backyard pool. So those are the phenomenon we talk about in learning sequence 1, in which we have the students interact with in one way or another. The storyline for us is how we take that phenomenon and turn it into those units. So what's the story that we want students to create or to understand by the end? So for learning sequence 1 in unit 1, we are looking at the persistence of an ecosystem, which is based on that availability of energy within the environment and how it cycles matter. And we focus a lot on the relationships within this ecosystem. Highlights from instructional sequence 1, of course, is the bottle biology project, with that being our anchor phenomenon. The students in our trials so far this year have really gotten into creating those bottles. And it's a fun activity that is hands-on. And even in our situation we are now with the pandemic, it's something students can do in class without having to be in a group if you so choose. It can be an individual project. We have a lot of modeling in this sequence. So we're going to start with modeling and drawings. We also have the seed redwood tree seed that grows into the redwood, and we have students measure the seed and then measure what the true tree would be and the difference between the seed and the adult tree. And then we use a modeling through a graphic story of the life of the tree for students to portray what they've learned. We have a gallery walk in which we have students do an I notice, an I wonder. And these gallery walks are pictures of different ecosystems like the rainforest and the savanna, those types of, it's a wide variety of ecosystems. Then we have students again model, but this time through concept maps. So we want them to create that diagram and show the relationships that they are seeing in the ecosystem. And as part of any ecosystem coming with energy flow, we have our food web. We have our human food web, we have the kids create food webs, and there's lots of times for discussions during this instructional sequence to have with your students and for your students to have with one another. At the end, we finalize the instructional sequence with that food web creation and scenarios of that ecosystem so that the students can talk about if something were to happen to this part of the ecosystem, what would happen to everything else? You know, talking about those interdependent relationships. To finalize our instructional unit, we have our evidence of learning. So what do we want the students to be able to do and show us that they've had the learning that they need for this instructional sequence? So we want students to develop a model to show and explain how the energy is transferred from the sun and is used by plants. We also want that model to show that through interactions between those producers, consumers, and decomposers, matter cycles through that ecosystem. Next, we want the students to also develop a model, and it could be the same model, to predict how changes in the ecosystem affect the flow of energy. So that's when we had that example of, okay, say there's a drought. So we have the students tell us, well, if there's a drought, this, and this is going to happen to this particular ecosystem and how it might affect all the species within. And that concludes basically our instructional sequence 1. So moving on to instructional sequence 2, where we have, again, we have the anchor phenomenon of the bottle. So we're still in that first unit, but this is the second learning sequence. So we're focusing more on the energy from the sun as radiation to use for life processes, and that some of this heat is lost in this process, but that this energy is then replaced by the sun's radiation. So we're talking more of the sun's bringing in the radiation, but some of it's gone. So how does it get replaced? Kind of having that conversation with the kids. So we're focused here on standard, again, 14. So again, our SAP is going to be constructing a model, and we're again showing the cycling of matter and energy. So you'll notice there'll probably some repeats in our SCPs and CCCs, and that is okay. So we're going to continue with the focus on the modeling and the energy of matter and the system overall. And we want to add to this the constructing of an explanation, because we not only want the students to be able to model this stuff, we want them to be able to explain to us what is going on and how they understand that. So the phenomenon changes just a bit here. We again have the same anchor phenomenon, our bottle ecosystem, to tie the two learning sequences together. But this time we also add a phenomenon of a fire, forest fire, energy pyramids, and a marine life ecosystem. So here we are going to move to the storyline of the transfer of energy in an ecosystem flows from one organism to another as food. The energy flow and loss can be represented as inputs, processes, and outputs in the model showing the relationships of ecosystem. So you'll notice there's a lot of similarities between the first learning sequence and the second learning sequence, but again, we're still in the same unit. So we're kind of covering that same standard. We've just kind of broken it apart a little bit. So the highlights from instructional sequence 2 is we start with a forest fire discussion. We present a picture to the students and we ask them what energy is happening in here. Where do you see energy? Where is it transferring? What's going on? And one of the main emphasis we want to provide for the students is, yes, there's a fire going on. Yes, all of the interactions going on in the ecosystem are happening. But the sun is also still shining. It is still providing energy into this ecosystem so that they can understand the sun is always providing us that energy, even if other things are creating energy as well, or changing energy or transferring energy. So it's all kind of this cycle that continues to happen. We also have an annotated drawing of an ecosystem in this instructional sequence. And we start looking at the energy pyramid. So we have a hands-on activity where students are using water to kind of understand the fact that there's some loss of energy at every step, that we have some loss in what happens and where does it go and why is that at every point of the energy pyramid. Then we start looking at a specific ecosystem and its energy pyramid. Then we finalize the instructional sequence with going back to our anchor phenomenon. Okay, your bottle ecosystem. You now understand, hopefully, the interactions that are happening in it. So create a model of the model you've created specifically in person. Now put it on paper. Describe those relationships. Construct that explanation of what's going on and where things are showing in your example ecosystem of the real ecosystem that you live in. The evidence of learning for us in this second instructional sequence is to develop a model to show and explain that food as chemical energy flows through a system, and that energy is dissipated as an output as heat, and that energy is continuously being replacing radiation from the sun. We also want a model to predict how changes in that ecosystem affect the flow of energy. So again, you'll notice that second one is very similar to the one in the first instructional sequence because they really tie together. So when we create an assessment for this, we'll probably have both sequences together because the EOLs, or the evidence of learning, are so similar, where the students could create one or two models to show us all of these things. So that concludes Unit 1. So for Unit 1, we had the anchor phenomenon of the bottle bioecosystem which the students create, and we kept referring back to it and having those conversations during those instructional sequences. So for Unit 2, we kind of moved to a slightly different situation where we have factors influence populations in an ecosystem. So for this one, we are going to change our anchor phenomenon, and we'll talk about that in just a minute. So our big idea is interactions between organisms in the environment and all of those types of interactions. So we're focusing on those, and that ecosystems are healthy when different species are able to meet their needs. So we're talking about that interrelationship that we had discussed first, but we're kind of going more in depth with it. And the fact that those relationships need to be healthy for a healthy ecosystem. So here we are looking at 6th grade standard 13, which again is develop and use models, but this time we're demonstrating the interdependence of organisms and their environment. So we're going to change a little bit on our SEPs. While we still have the model, we want it to be based on evidence, and we are adding the analyzing and interpreting data piece. So we want students to look at data. We want them to construct data. We want them to analyze it and interpret it. For our cross-cutting concepts, we are adding cause and effect, patterns, and stability and change. So you'll notice we're making a shift from our Unit 1 in life. Here we're looking at how do the relationships affect each other, what patterns do we see, and how does this create stability or change within the whole system of the ecosystem. For our using science, we are looking at how scientists use models to represent those relationships and the fact that we need to be accurate in those descriptions. So you'll see some major changes here between the first unit because we're kind of shifting our focus a little bit on our SCPs and a lot on our cross-cutting concepts that we're bringing in. Our phenomenon here is we're going to go to a bigger ecosystem of Yellowstone National Park. So we're going to use that as our anchor for both learning sequences. For this first learning sequence, we are also looking at specific deer populations, and we have an activity that actually puts the students in the kind of role as a deer. And then we have specific interdependent relationships in ecosystems. So we're talking about specific relationships within a specific ecosystem, and we have several of those. We are talking specifically about the ecosystem of the boreal forest. And in that ecosystem, we are looking at the lynx and the snowshoe hare for graphical data to use and analyze. So our storyline is that the graphical patterns can be used to identify cause and effect relationships in an ecosystem. Healthy ecosystems have multiple species of different types and are able to meet their needs in a relatively stable web of life, and that these observations can be represented in the graphical models. So here we're changing, where in Unit 1, we were doing a lot of diagrams and drawings for our modeling. Here we're going more into the graphical side, graphs, charts. Highlights from the lessons from instructional sequence 1 from Unit 2 is we are going to analyze graphs using the I2 strategy. The I2 strategy is a fabulous strategy for students, especially those that are just beginning to analyze graphs. I see, it means. So students look at a graph and tell us what they see, okay? Once they tell us what they see, what does it mean? So it's immediate. I see the graph go up, it means something was increasing, whatever it was. Second of all, our highlighted lesson is the Oh Dear project from Wild Activity, where this is an activity for students to participate and have fun and understand how different things affect a deer population. I was able to modify this for online learning where you use a hat. The key feature there is students need to be on camera. So it is adaptable for the online environment, which I thought was fun. But students really got into it. I had teachers that did it in person and virtually, and they both had success this year. Limiting factors T-chart. We like to use our charts and our thinking maps here in Higley, so we try to include those as often as we can. The next highlight from this unit is an M&M activity, which you can find online from Young Scientists program. And it's a fun activity using M&Ms that students can use to kind of figure out some of these limiting factors and how needs must be met to survive. We also will be doing a lot of research in this unit. And so students will be researching and model ecosystems that they have researched. We are looking at the hare and lynx graph, and students are going to create a story based on the boreal forest ecosystem in regards to the hare and lynx. And then we are coming back to our anchor phenomenon of Yellowstone ecosystem, comparing and contrasting with the student's personal ecosystem. So in this activity, we ask students, okay, what is your ecosystem? You know, who do you interact with on a daily basis? Who do you need to survive? You know, if you were, you know, what's that world around you? That takes a lot of thought and comprehension for students to kind of make that comparison. And so that's a very thought-provoking assignment for students. And then how does it relate to the Yellowstone ecosystem? You know, what piece in the Yellowstone relates to what piece in the student's ecosystem? It's a fun task. So our evidence of learning specifications for the instructional sequence 1 in Unit 2 is to construct, analyze, and interpret data to show graphical patterns in population growth and stability due to competition and predation relationships. So here we want them to graph some competition and predation relationships. Then we want them to develop and use a model to show the cause and effect relationship between an organism's population size and the resources. In addition, that model should show how the relationships of interdependent organisms maintain equilibrium, creating a healthy ecosystem. Again, bringing in that competition, predation, mutualism, all of those topics. Also, that model should show the cause and effect of what happens if a variable in that system changed within an ecosystem. You notice that's, again, very similar to the EOLs from Unit 1. We, again, want the students to be able to predict what is going to happen within their ecosystem if something changes, so that we truly know the students know that interaction piece, that we know how they interact within each within that ecosystem with each other. Instructional sequence 2, again, has our anchor phenomenon of the Yellowstone ecosystem, but this time our big idea is based on human activities. How do human activities affect the Earth's environment, and how do they alter ecosystems and affect all living things? So here we have 2 new standards. We have 6th grade standard 11 and 12, and you'll notice the SEPs for these standards changed. So we have use evidence to construct an argument and engage in argument from evidence. So those are going to completely change our SEPs for this instructional sequence compared to what we've done so far. So here we're going to use the engaging in argument. So we picked the elements, construct and use and present an oral written argument, and compare and critique 2 arguments. And then we want constructing explanations and designing solutions. So we want them to apply the science and explain what's happening with the phenomenon. For our cross-cutting concepts, we are looking at scale, proportion, and quantity because we want them to understand systems may change with the scale. We want stability and change in there because, again, we're talking about how ecosystems can change with things happening. So we want to talk about the stability and change over time, over how something sudden may happen, or that it may take some long periods of time to happen. Our using science comes back to clean water, adequate food, and improved medicines have increased human life expectancy. But at this time, population growth has increased demands on resources. So we're talking about how human impact has impacted the environment in this case. So the phenomenon, again, we start with Yellowstone National Park, our anchor, but we're going to go deeper into Yellowstone this time. We're going to be looking at the wolves' reintroduction to Yellowstone. We're going to be looking at various species within Yellowstone National Park. We're going to be talking about ecosystem dynamics. And we're also going to be looking at a variety of ecosystems with some research. So we're going to dive deep into the Yellowstone Park, but then we're also going to pull in some other ecosystems to bring in so students can see how it relates to one another. So our storyline here is changes in one part of the ecosystem can impact other parts of the ecosystem. These changes, large or small, quick or fast, to the Earth's environments from natural or human activities and advancements can have positive or negative impacts, often unintended for different living things like damaging or destroying of natural habitats and causing extinction of species. So the highlights from the lessons, we're starting with the wolves of Yellowstone. So in Higley, we like our thinking maps, as I said earlier, so we're using a bubble map. So we're having students watch this video and we're stopping it at a certain point so they can create a bubble map. Because this video kind of gives a whole story, we want them only introduced to the story at first. And then we're having them create a food web of Yellowstone. So we're bringing back what we learned from Unit 1 and applying it here to the Yellowstone in Unit 2. Then we're going to talk about Wolves of Yellowstone Earth, a new wild role-playing activity. So this is where students put themselves into the roles of what people and other our government agencies and everything did during this time at Yellowstone, where we were dealing with the wolves and what was happening and the reintroduction and playing different parts. So it's that argument and constructing explanations piece. It's a really fun activity for students to participate in and looking at the research from what happened back then. Reflection and discussion are a huge piece of this instructional sequence. We want students reflecting. We want students discussing and having those thoughts about what's going on and what to do. The wolf reintroduction research activity and timeline. So again, we're having students talk about what happened during the reintroduction, how it affected the ecosystem, and everything else. To me, it is such a phenomenal story of how many things changed and what changed when the wolves were reintroduced to the ecosystem. Because the things that changed in the ecosystem, I can't imagine some of the students would imagine that they would change. The way the water moved and all of the species that came back. It's just phenomenal. Human impact and invasive species research project is the next thing we do. So students can look at specific natural and human things that occur that help or harm an ecosystem. And so students have a little bit of choice here, and they can do different invasive species, and then they present this. They also try to persuade their classmates and others that their invasive species is the worst one. You know, which one is worse than the other? They're trying to kind of compete for that, because there's a competition in the activities for a federal grant in which the students are going to present this project, and then hopefully you're going to have set up a grant committee who can vote on the students' persuasion and their presentations of saying, I would give the money to this to help sponsor this problem or to help fix this. And it kind of helps create a kind of involvement for the students. So our evidence of learning here is going to be engaging in argument. So we want students to show us similar or different evidence to show how human activities through changes can damage the balance of the biosphere and or cause extinction. We also want that argument to have evidence to support or refute a claim using scientific reasoning. So we want the students to bring in that reasoning, to bring in that science, and show us that the system could have positive or negative impact on the biosphere because of what's happening with the science. That right there is a summary, very quick, very fast, of the 6th grade life unit. And I hope you are able to enjoy it and practice with it, but I'm always available for questions in addition to answering any questions we have now. Savia, are you able to, I can't see the chat.
Yes, nope. Nope, it just, Michelle said, thank you so much. I've been focusing on the chat too. There haven't been very many questions.
All right, I'll turn the screen back over to you then.
Awesome, thank you. See, I'm gonna go ahead and
Please.
Yeah.
Thank you. I couldn't find that button there. Thank you everybody for coming. And I know I talked fast, so if you have any questions, don't hesitate to contact me at any point.
So thank you so much, Leslie, for sharing your unit. That was awesome. I put in the chat earlier, this had been recorded, and so it should be up on the AST website within a week. But also Leslie's unit is on the ASTA website. And so it's easily accessible with all the resources. We appreciate Higley helping support our science community in innovative ways to reach students through the 3 dimensions. Arizona Science Teachers Association has other exciting experiences coming up, and I hope you'll check out the website to see more. And we'll send everyone an email who attended today with links and any resources. So there'll be a PDF version of this presentation. And I will be sending out the PD certificates this afternoon. So thank you for your attendance. And if there are no more questions, we can end the meeting soon, but please feel free to continue to ask questions. It's that wait time in Zoom land, right? Thank you everyone for sharing your morning with us. And we will be doing another presentation at, Leslie will be doing another presentation at 10:30. Do you want to talk just a minute about what that is called and what it will entail, Leslie?
I would love to. So through this process of this professional development we were introduced to a process to create 3-dimensional units. And I'm talking about the first part of the process, creating blueprints, which is called Tool 1 this morning, later on. And I love this process. And I'm using it currently now, creating stuff for my district, and I'm helping the teachers go through the process as well. I found it very helpful.
Awesome. So if you would like to sign up for that as well, just shoot professional development an email, and we'd gladly send you a link to that Zoom meeting in about an hour. So awesome. Thank you very much, Leslie.
Thank you.
I'm going to go ahead and stop recording.